Hello friends, welcome to my channel. Today we will discuss about the basics of microcontrollers. What are the architecture of microcontrollers and what are its applications? So microcontroller is a type of computer which has CPU, RAM, ROM and other peripherals embedded in it. All these things are embedded in a single chip and are capable of performing different operations that will I will discuss later on this video. So there are different types of microcontrollers from different companies like AVR, ST, Infineon, and other companies as well. So what actually the microcontroller is? We will discuss its architecture here. You can see over that image that there is a microprocessor, RAM, and ATD converter, oscillators, ADC, other several things are embedded on a single chip. That means it is capable of performing different operations. Like we can perform an ADC conversion here. Like we can compare any timer operations with the help of microcontrollers. So different operations we can perform with the help of microcontrollers. Basically what the thing is that here there's a CPU which performs all the arithmetic and logic operations here. Okay, you can see over the diagram here there's a CPU. All these things timing and the data is transferred here like with the data bus here, and different address are assigned to different peripherals. There's basically a memory map for the microcontroller that you can like search on the data sheet of that microcontroller. Basically all these peripherals are assigned different address on the address bus. Okay, different peripherals at different address that we have to select while programming the microcontrollers. Okay, and the other thing is that the peripheral you want to access, that you need to provide the address of that. We will see that thing in the programming. So basic thing is that there are different, like you can see over the diagram here, there's a serial port, input output port, bus control, there are two timers as well, and there's a CPU who's controlling all the arithmetic and logic operations here, and there's an intercontrol as well. So basically different peripherals we can control with the help of microcontroller according to our application that we need to understand. So we can look at a basic example of LED blinking here. So this is example of AVR microcontroller in which we like uh, toggling LED with the help of a delay here. So what we are doing here, we're defining some macros. Like for the first macro we define here for enabling the frequency, so that we can perform some clock operations, and there's a header file that we need to that includes the different files. Okay, so what we are doing here, like we are writing a code in the main function. Okay, and we define some header files like for io.h. We define here like for input and input and output operations here, and util delay is a header file which will include so that we can perform the delays operation here. So initially what I did here, I performed the command ddra, which is like enabling or setting. That means we are like enabling the port whether it will behave the input or output. Here in the example, we want to set the output port, so here we declaring it the output. uh, and other thing what we are like, we are declaring the output by defining the as one. Okay, and port a is a in which the command by which we can write the logic. Basically dd ddr is like for defining whether we want to use it as an input or as an output here. So here we are like just defining as the output, and in port a in infinite. So this is infinite loop in which what I am doing here in port a, I'm writing one on the zeroth pin, then I'm giving some delay. After that I'm passing zero logic to that pin after delay, and that loop will uh, again repeat that cycle again. So in this way it will repeat the cycle, and in this way that LED will toggle. So similarly we can write different codes. Main thing is that we should understand the logic behind the code. That's a main thing I would say. If you understand the logic, then you can like able to write different codes very easily. Like suppose you're writing some timer code, then you should have said what will the basic operations of timer, what basically what the registers are doing in that peripherals, how can you access that peripheral registers, what are the PD scalars in that register. You have to read the that peripheral register thoroughly. Basically understanding is very much important. Then you can easily write the code writing is not that hard, but logic creations will get from only paraphrasing. So that's all about the video. Thanks you so much for this.